Hi everyone, and welcome to this week's lesson on how to create a correlation matrix in SPSS. So the first thing we are going to do is we are going to download our Youth Risk Behavior Survey 2013 dataset from Titanium. And this is actually the dataset that you will be using for your final project. So it's great to be able to get familiar with it now, because you will be getting even more familiar with it as we start to develop your final projects. There are two different views in SPSS. There's the variable view here, which shows each variable and all of the details about the variable. So the name, in this case, question 1, the label, which indicates what the question actually was, how old are you, and then the values. So each of the values and how they're coded is shown here. So for example, for the question, what is your sex? 1 is female, and if you click here, 2 is indicated as male. If you click here on Data View, the Data View tab shows you the actual values for every single one of the observations in our data set. So for question 1, these are all of the answers that each individual answered for question 1. If you scroll to the bottom of the data set, you can see how many people actually answered the questions. As you can see, we have 13,583 students answered the questionnaire for the Youth Risk Behavior Survey in 2013. So what I'd like you to do is to open the handout for this week's assignment, and in it you will find a list of all the variables that we would like to analyze using correlation. If you remember, correlation is looking at similarities among patterns. So similar to the Simon Says game, what we're looking for here is questions that individuals answered using a similar pattern. So for example, in our question data set, we might want to know, for those individuals who often drive with a drinking driver, what other behaviors in this list might they often do? And likewise, for those who rarely drive with a drinking driver, what behaviors are they more likely to do? So we want to look at both positive correlations as well as inverse correlations or negative correlations. So we'll start by going to Analyze, Correlate, Bivariate. So let's analyze, correlate, bivariate. So once we've got this input box open, what we'll do is we'll look at our list of variables, and we will go ahead and add every single one of these variables from our list of available variables here into our list of variables that we are using for a correlation. So the first variable is question number 10, how often do you ride with a drinking driver? We will go ahead and add that in. And these questions are listed in numeric order. And as you put your mouse and click over the button, it will show you in parentheses the question number. So we want to add how many days they text or email. Question 12. Question 13, how many days they carried a weapon. Questions 16 and 18, they felt unsafe at school. And 18, how many times they were in a fight. 22, if they were physically hurt by dates in the last 12 months. And 23, forced to do sexual things by dates. If they have been bullied at school in the last 12 months, if they've been electronically bullied, if they've felt sad or hopeless, if they've ever considered suicide in the last 12 months. So all of those. And then how many days they've smoked, how many days they've drank alcohol. how many times they smoked marijuana, how many times they've used prescription drugs without a prescription. So questions 47 and 56. How many times they've injected drugs and fasted to lose weight. How many times they drank soda in the last 7 days and the hours of sleep they had on a school night. And finally, we're going to scroll all the way to the bottom to find body mass index and add that to our list. For options, we are going to exclude cases pairwise. We will click on Pearson's correlation coefficients, two-tailed, and flag significant correlations and hit OK. So what we have here is our output table with our correlation matrix. And in this data set, what it shows you is for each crosstab of each variable, it shows the correlation coefficient, and it indicates with either 1 or 2 asterisks if the value of the correlation coefficient is statistically significant. So in this case, that is statistically significant. And if you look at the very bottom of this table, it indicates it's significant at the 0.01 level. So that means this result is not likely to be due to chance. So if we were to look in comparison at all of our values here, what we can see is all of these first correlation coefficients are statistically significant all the way down through the data. However, although they are statistically significant, as we discussed in class, there is a difference between significance and size. So in this case, the result is highly statistically significant, and the size is a low to moderate association of 0.21. This coefficient is also positive, which means that when this variable goes up in value, this variable also goes up in value. So we can assume by this correlation coefficient that individuals who text or email while driving, the more they do this, the more often they ride with drivers who drink, and vice versa. In the same way, individuals who get in a fight in the last 12 months, the more often they get into fights, the more often they ride with drivers who drink. If this value were to be negative, so for example, if I look at carried weapon to school and have you been bullied in the past 12 months, we can see a negative value, which means there is an inverse relationship. So what this means is the more someone has been bullied at school, the less likely they are to. So for example, let's look at the value of having been bullied in the last 12 months at school and comparing that to how many times you've been in a fight in the last 12 months. What we can do is when we track those two variables and compare them against one another, what we determine is that there is a negative correlation, which means that the more often this happens, the less likely an individual is to get into a fight. Sometimes when you see a negative correlation, there may also be an issue with a variable being negatively coded. So for example, in this case, when we look at how many days did you feel unsafe at school, and we look at the number of times the individual was bullied, we see a negative relationship, which seems to suggest that the more often someone was bullied, either electronically or in person, the lower number of days that they felt unsafe at school, which doesn't seem to make sense. So here's where we would go back to our data, and I would look at the variable view, and I would check on those two questions. So I would look at this question, how many days did you feel unsafe at school? And it shows that the higher the number is the more days that they felt unsafe at school. So that one is not negatively coded. Next, we will look at the question, have you been bullied in school over the last 12 months? And what we can see here is that yes is a lower value of 1 and no is a higher value of 2. So what this means is this particular data set is inversely coded or negatively coded, and therefore the reason why there's an inverse relationship between having been bullied at school and the variable of the days of feeling unsafe at school is because the more times you've been bullied at school, the lower number you would have in this score, and the more times you feel unsafe at school, the higher number you would have in this score. So in this way, what you can see is that the result does indicate that individuals who feel unsafe at school are also more likely to be bullied. The correlation number, however, is deceptive because the bullying question is negatively coded and shows an inverse relationship when in fact the more you have been bullied, the more you will feel unsafe. So what you'll want to do is to save down your correlation matrix output file. So output Shimazu correlation matrix, save that, and then what you'll do is you'll use this data to answer the questions that are on the handout. So good luck everyone and have a great week.